Okay, so yesterday we studied how magnetism exists, what causes magnetism, and the one that we're most um, interested in is the ferromagnetic case. There are other types of magnetism, but the ferromagnetism is the one that's most important, especially for this course, in creating electricity and also running motors and so forth. Okay, but today we're going to talk about other aspects, other things that we can do, applications where we use magnetism. Okay, we know now that different materials that we can use, and mainly the most basic one is iron because iron has really good properties. It can be magnetized, and when you can create permanent magnetism, or as we know, we can eliminate the magnetism by three different ways of doing that. The simplest way actually is to run it through a coil with alternating current. Okay, you can run it back and forth and so that you randomize the domains. The other way is just kind of sort of destructive by heating it up to Curie temperature, in which case you lose all your magnetic properties. You get them back as you get down to regular room temperature, but you've got the magnet, you've lost you've lost the alignment, so you've got no remnant magnetism. You have to recreate it. All right. But the one interesting uh, tool that we have for magnetism is called a solenoid. All right, you know that the solenoid is basically a coil of wire passing with DC current running through it. Okay, and inside that coil we place a bar, a ferromagnetic bar, and we can call that a plunger if it's, for example, if it's tied to a spring. All right, and all we have to do is energize the current through the coil, and that plunger will move to a midsection around in the coil. Okay, so basically, it's a push system or a pull system, depending on if you want to open or close a valve. Okay, so we use it to create relays, to create multiple types of switching devices. All right, so just activate it when you need to. For example, if you're warming up your house, you relay um, turns on the heat or turns it off when the temperature is too hot. That's that's what you do. Okay. The other way that we can use a similar solenoid-like uh, part is called a proximity sensor, which I'm very familiar with because we design such things for aircraft in the place I used to work at, the aerospace company that I worked at. Proximity sensor, I think I told you, basically tests reluctance. All right, reluctance is essentially opposition to electric field, a magnetic field. Okay, a magnetic field. So that's dependent on the distance of the magnetic core to a ferromagnetic material. All right. If the ferromagnetic target material is far away from the solenoid, okay, then that's a loss of magnetic field. So the reluctance is high because high reluctance means um, sort of like high resistance, all right? But if that target gets close to the sensor, okay, to the coil, magnetic core, then the reluctance gets greatly reduced because the ferromagnetic material will attract that flux. Okay, so you're increasing the flux and therefore slowing down the reluctance. And that's used basically as where it says proximity sensing to tell you how far a target is from the sensor itself, right? So we used to use it on doors to make sure the aircraft doors were all closed and locked and latched, okay, that the flaps on the wings are deployed or not deployed, the landing gear is deployed, is dropped, or the landing gear is sensing ground level, all those nice things that you need to know when you're flying an aircraft. And I imagine you use a lot of those things also in a submarine. Mainly, I would think you would use it in the to make sure that you latch any kind of doors that need to be closed. Okay, um, so the other system that is is considered in using electromagnets is rastering. Rastering is basically a line-by-line data uh, giving intensity of an electron beam, okay, onto a cathode ray tube, all right, and sometimes something else. But for example, sonar and radar and sonar using the old cathode ray tube technology, we need something that sweeps line by line to give you blips or whatever at specific points on your screen. Okay, that's called rastering. All right. Another way to use that type of mechanism is to use electron microscope. Now, there are two kinds of electron microscopes that are popular. There's the scanning electron microscope, and there's the transmission electron microscope. Both of them basically have an electron beam that's shot through some electromagnetic lenses, and the electromagnetic lenses cause rastering, and they also cause microscopy. All right, they expand an image or diminish an image. So that's the other way of using electromagnetic components. And those are all shown in the presented in your PowerPoint presentation. Uh, and there, I'm sure that you can think of others. And we will essentially go through those on the PowerPoint presentation. Then we'll have some questions for homework to do. Now, some of the things that I did, you may disagree with, and hopefully you find other ways of doing it. I'd be very interested in knowing what the other way, or probably the better way of connecting things are. So that's your homework for tonight. So carry on and give me a call if you need some more help. So take care.